Again, this is Old Man PHP. I create PHP video tutorials for you guys who want to learn a new skill, compete with the young crowd. This is video, as you can see, 125p. What I want to do is talk about some few things. Is what's under the hood of this system, right? Like the database, security, all these little things. So I'm going to have a slide, and hopefully I can show that over here. Let's see. Oh, here it goes. And that's what's under the hood. And I wrote down as best as I know. If I have, hopefully there's no misspelled words. Sometimes I can't see well, and I'm dealing with a computer that's kind of messed up, really. And it's terrible, basically. It's terrible. So as you know, as you can see here, it's a visual breakdown of why the relational database survives scale. Why, when you deal with the MySQL database and how you write things, not the basic stuff, the encapsulating stuff, dealing with the power that it has. It's fantastic. I used to deal with Oracle. I used to deal with Sybase. But MySQL, oh man, I mean, it's just as good as my Sybase, and it's all the commands that you use is the same. It's really great. You can experiment it, and you got it on your box. If you can bring it down in your box, but in my box it's all destroyed. So I'm dealing with a database that is sitting up in the cloud, and we're using the cPanel to get to it. One day I'll show you how that looks. All right. So on the next one is about meeting the warehouse monster. When I was doing with this the first time, long time ago, when I was doing it for I think it was an Indian company where they deal with those little flowery things, dry, they smell, what is that, potpourri? They had all kinds of different things, fragrant and all that in the warehouse. And it's always been a problem because every time they were like, once again, sorry about that, guys. For some reason, I started the video and now I got an HMI in the air. So that's always fun. So right here, right, what's the basic system drops the money, right? So the standard software companies, deal with the same type of inventory system. It might be a little different, it might look a little different, but it's basically the same thing. Especially if you have a PO, purchase order system connected to it. So the standard software operates in the silo, right? Your inventory, like we say here, is lists. Don't directly know when purchase orders are drafted, or the POs don't know when the shelves are empty, because it was weird. But when we built it, I built it in a way that you can, once it goes, once you SAP it, which I'm going to show you in another video, the scanner, you put it in, it goes into the database, and then it goes into these conveyor belts to different parts of the warehouse. Where they keep, this one keeps all the candles, this one the wicks of the candles. It was like weird the way they had it, and we did it like that. But it's so big, sometimes you got somebody to walk back and forth to check it out, and the system will tell you if something, you're running out of this, you need to order this, and you can order the stuff right through the system instead of just, getting to your office and say, hey, listen, you can do it all through here. So that's a good thing. It really is. So 40% labor loss, right? That's crazy, because if things are not organized, everything can go haywire, man. So you spend nearly half the day, chasing down inventory records, right? And then you have to double bind. Over the ordering is like the first, something happened to my phone here. What the hell? What is it? I'll tell you, man. The more technology you get, the more this can break. So when you double bind, right? Sometimes you don't know, and you end up buying more than what you have, what you think you ran out of, and it ends up being that no, it's sitting in another part of the store. We got like 50 of them, and then you'll be like, oh, everything is inaccurate. The system is no good. So that is the monster. That is the monster. And then you, of course, you got to deal with the security of the whole thing, right? You have to really deal with the security. So if you go to the golden thread strategy, right? So you got the relational database, right? Remember I told you got when you create the forms, and you got your primaries, and you got your form, but then you got all the tables and how you get them connected, right? And all that using the form. Now the relational database, instead of manual bridges or tables using persistent primary to foreign key locks, every other statement mirrors the stock. The limits automatically. And what is a relational database? It's the SQL, which we're using, MySQL, right? Is the actual relational engine. It's like the core software component of a database management system. Then you see them. It's called DBMS, that processes and optimizes and execute your SQL queries. The SQL queries, the ones that says select this from a table, update this from a table, delete this record from a table. Those little SQL statements, that's what we're talking about, right? So you execute the SQL queries, and to see what you have. You want to store things, right? That's when you do the input, and then you want to retrieve stuff, right? And that's when you use the select statement. And it acts like the brain of the database, translating the high level SQL code into lower level physical disk operation. So the core component of a relational, if I can remember, engine is like the parser, right? That checks the incoming SQL query for the correct syntax. You notice how you see me, I do a command, it's a problem with the syntax, and you go in, this what does it, right? So it verifies the table, column names against the database catalog, translates the text into a logical query tree. Then you have your optimizer that evaluates to multiple extension strategies, such as an index scan versus a full table scan. Is there an in between? We'll have to look that up, but it uses data statistics to select the most efficient plan based on the cost of how you're going to do things, right? Then you got your execution plan generator, right? That converts the chosen logical strategy into an executable recipe of a physical operation, like a nested loop, hash joints, sorting algorithm. You've seen those types of things already. The nested loop, the hash joints, and all that. You even saw the sorting algorithm, right? And then the execution engine, right? It's the one that does after all that, and then it executes. That's the runs the plan, interacting directly with the storage engine, like to fetch or modify data, or to put something in it, or to apply filters. It returns the final results to you, as long as everything is done in syntax order. You have to do it right. Then you got the atomicity database queries, executes all or nothing if a network blips. That's the one I call a hit. When it hits, occurs mid-order. That's why I used to do those duplicate things, because you could get a blip. You could get something that's, but if you got a backup thing that will it will do the thing for you, then you have a more or less chance of being down for a while. So the database rolls. Oh yeah, you got the database rolls back to keep the records clean, and the atomicity. That's the, what is that? That's like the database is that all or nothing property, ensuring that the series of like database operation within a single transaction either completely succeed or completely fails, leaving no partial updates. It is like an A in the acid, atomicity, consistency. What is it? Isolation. There's, what is that? What's the fourth one? Durability, right? And that's the reliability of the model, right? And how that works, well, I'll tell you. What it does is it commits, right? So if every operation within a transaction execution successfully executes successfully, the database permanently saves all changes to a disk, right? You know that for a fact, right? And then you got that rollback. If even a single statement fails, like due to a power outage, which I get a lot, error, constraint, violation, the database engine aborts the transaction that you were doing and reverses every change made up to the point. I used to hate that. I used to do some things. I was like, I can't believe this, blah, blah, blah. And even sometimes when you don't see there was a problem, it must have been a blurb. Somehow something got a hit on the way to the database. You didn't see it, but somehow it's just a weird thing. And I'm glad that they had that rollback. And then, of course, it keeps track. Then I don't know if you play around with it, you'll get something like, hey, there's an error log. That's like the log file. That's to achieve this, right? The database engine, right? It writes and changes to a write ahead of log. I think it's called WAL, right? Before updating the actual table. And if it fails, it occurs in mid-transaction. The engine reads the log to reverse the incomplete operation. That's a, hold on one second, guys. I gotta take a sip of this. I'm doing this video, but before this video, I was on the phone with somebody that were having problems, and I was talking a lot, so excuse me. Let me see, what was going to do that? I also gave blood, man, because I have to go see my cardiologist. I'm in trouble, guys. I'm in trouble. I don't know, man. I don't know. Oh, by the way, guys, my mother died a few days ago. She was 95. That's why it took a while for me to do some of these videos. Yeah, I'm sorry and I apologize. Just, I don't know, so much crap going on. Mom. I told my sister to, forget it. I didn't get to talk to my mom. I wanted her to see me one last time. But she was always proud of me because she used to see some of the things I used to create. And she knew I was a good systems engineer, even though she didn't know what that was, but they used to tell me that, you're a good system engineer. In Spanish, of course. Now, the practical example, let's say like a bank transfer, right? Let's say you consider moving like $100 from account A to account B, which requires two distinct actions. First, it deducts the 100 from the account A, then it adds the 100 to account B. Now, without atomicity, a system crashes between, let's say, step 1 and 2. This is what I'm talking about, like the head of the bird, like they keep talking about, will cause that $100 to permanently vanish from the ecosystem. Do you believe that? Now, it guarantees that if step 2 fails, step 1 is automatically undone. Isn't that cool? It really is. And then you got your modular blocks. The one help, what is that? Our helper module. I should have said something else. Modulates operate independently, plug and play. Modulars let you scale features without rewriting code. Remember, those are like pieces and third apps. What is that? What was that I'm trying to say? Party ads, right? That will help you out and all that. So the modular blocks. Okay, modular blocks is like in SQL, a self-contained section of code. That's what it is. And typically using that begin and end keyword. I don't know if you've seen it in some of the code. Because right now my code is, it's mostly PHP and SQL stuff, right? You've seen it already. I've gotten into the inner core, you see that inner joins and outer joins. It gotten big, but there's things where you can really add a lot. You can do like a lot of the programming, well, not the actual PHP stuff that you need to do, but some of the SQL stuff you can actually let the engine do the work. So I don't know if you've seen it, we ran into it. Like it starts with the word begin and has a whole bunch of stuff going on, and then it ends with the keyword end. Now that allows you to group multiple statements together and manage local variables. It controls execution flow. They are the foundation of procedural programming extension in SQL, such as, you ever seen this thing called T-SQL, SQL Server, /SQL. That would be like Oracle, right? Sorry, guys. Oh my God. Oh man, a little itch. I don't know where that come from. So the core characteristics of the modular blocks, right? So you got the anonymity versus the permanence. Blocks can be anonymous, execute on the fly with the script and the migration, or name the save permanently in the database. That's like stores, procedures. You've seen them, or functions, right? Or triggers. We haven't done a lot of that trigger stuff, but I think I might have done some. Maybe not. Maybe I'm just thinking about something else. But then you got variable scope. You can declare variables that exist only within like the confines of that specific block. You know what I'm saying? And preventing naming conflicts. That's why you have to have namescape. That's what I call it anyway. And then you got the control flow. They allow the use of loops. You can use while, and then you got conditional logic like if and else, and of course your regular error handling steps like try, catch, or exceptions. You see that, right? Try this, catch if there's a problem, and then you do some stuff if there is a problem. If there's not, it keeps going, right? And then you got your typical structure of a block, and most SQL procedural blocks are divided into 3 distinct zones. And remember that, because I used to have a hard time trying to figure that out, like way back, and they kept telling me about it. So you got the declaration section. That's where the local variables, cursors, data types are defined. Then you got your execution section, that the mandatory core with the operational SQL queries and business logic run. Then you got of course your exceptions, right? Section, that's the one that does the error handling zone that catches the runtime failures and manages rollbacks or logging. And when you get an error, you get a login. You've seen that before. Then you have, let's go to the next, let's go here. Where is this? I'm yo, dude, I'm completely confused. Something is wrong with my. Where is my stuff? Oh, huh. What was the other thing from before? What happened to it? I don't see it here. Ugh. Okay, so we got it here. Okay, here goes the security here. And you know, we everything that we have done before, from the simplest being redundant, remember way back, the security stuff that comes out of the form before it goes to the database, you got to do all kinds of stuff, check for safety, check for injection, check for all these little things, right? That's important. That's really important. So the IP shield guard is encapsulating the system code. So, like, to scale our business safety, the secret formula must stay internal, right? You can't let people see what it is that you're doing, because you gotta hide these things. So our software hides the structured database triggers behind robust. I wonder if I spelled that right. Class abstraction, right? And our client gets a beautiful and uncomplicated user interface, while the database safe lock works cleanly behind the impenetrable backend shield, right? You got the nice forms, you got all this, but when you hit that submit button, boom, it's protected, right? Because you're going through all the process before. That's why I always tell you, do the prepare statement. Do the prepare statement and check for different things and get rid of stuff. If somebody puts a little accent mark or whatever, change it to the entities, and then you'll be okay, you know. Okay, so excuse me. Let's take another sip. You guys got coffee? Take a sip. I drink water with lemon, and I'm talking about the whole lemon. I grind that whole thing into nothing. I mean, skin and all. Uh, so when you encapsulate the system code, that's practice of hiding low-level database operation, complex business logic, or systems configuration behind a simplified, secure interface. You know, you've seen it. I've done it enough that you can kind of like, wow, look what he's done. And in the databases, this means like wrapping raw SQL statement inside modular structure like a store procedure. That's one thing we haven't done, the store procedures, but we will. And you got your functions and your views, that's a part of the database. And you got the database packages, so users and applications interact with the interface rather than the underlying table. And why encapsulate system code? Why? Well, because when you because security and access control, that's important. Users can be granted permission, right? You've seen it. I haven't shown you that because it's really not an SQL thing. I've given you pieces that way you can kind of use, and you built these things and say, oh wow, this stuff works. Then you can go ahead, because you learned a lot of that PHP stuff, I hope you did, and then you can say, okay, let me play around with it, see why, okay, oh, I see. And that's the only way you're gonna learn. You gotta do the stuff, right? So so users can be granted permission, right? You can, when you do like the database stuff, like the username, like who's gonna do this, that, and who's not. Because a lot of times you're dealing with a bunch of people that are working with you, and they're gonna be doing some things, and maybe they can't do all the things you do. And that's the permission stuff. So permission to execute a specific store procedure without giving them direct. You know something? I'm gonna do a whole. My friend's gonna say, "See, I told you so." You're telling me about, oh, the SQL, you gotta do a whole thing of SQL. It's good that you're showing this and that, but a lot of times you gotta do a whole, I don't know, what do you think, guys? Maybe a whole set of videos on just the SQL stuff. You know, because I show a lot of the good things like the select, the update, or the delete, right? I've done that, right? Which, you know, updates and delete stuff, and also show you that protecting the sensitive data, right? Maintainability and reusability. If a business rule or table schema, use the schema changes, you only update the code itself inside the capsule, the procedure, you know, and in one place rather than updating, you know, dozens of external application scripts. You can have it all one, you know, one thing, and easier to keep track. And then you have your performance optimization, right? That's enclosing the code within the database modules that allows what is a relational engine to compile, cache, reuse execution plan, reduce parsing overhead network traffic, and then you have your abstraction for developers. Like the front end developers don't need to know complex table joins or indexing structure. I am a full stack, so I do the the design, so when I'm doing the stuff. But if I go to a place where it's big, right now I have nobody's actually helping me do things, but I wish I did have I did have one, but got himself a job somewhere else, and that's it. All these little projects that I had, well, I'm doing it by myself. Anyway, the front end developers, right? They don't need to know that stuff, and they simply just call a standardized interface like the exec, get custom orders and stuff, that kind of thing. Plus, they'll call the DBA guy because that's the one that's gonna do it. Most of the time, you're gonna do the PHP stuff, and if you're doing stuff from a form into the database, you gotta have at least all this basic stuff: the SQL, the index, the updated, you know, all these little things, the delete. You need just to know all that stuff. So let's go to the next one because it's getting kind of like, why did I, you know, dude, I just messed this up for some reason. Why is it that I'm having, why did it, this is the most strangest thing ever. I had these other, I don't know. Don't tell me I deleted those things. Anyway, the Loctite database integration, the cascading operation, you know, when the stock changes are made, the related tables automatically align instantly. By programming cascading rules into our database design and deleting and updating a record trigger automatically adjusts that whole thing for you, and this completely eliminates the possibility of ghost entries or dead orders remain. Guys, it looks like I might have to call this short because I just got hold on 1 second. And then okay, what was I doing? What was I up to? What was I? Oh, so we do the cascading operation. I'm sorry. I thought it was somebody else and it ended up being my partner. So cascading operations are database rules that automatically propagates an action such as an update or delete from a parent table to an associated row of child tables. and they are defined a foreign key constraint to maintain referential integrity without requiring manual or multi-table code updates. Cascading is it's really good, because when you like for instance the common types of cascading operation, right? So you got your delete cascade. So if a row in the parent table is deleted, then the database automatically deletes all your corresponding rows in the child table. And deletes the customer automatically purchases all the other orders, right? So you got an updated cascade. So if a primary key value in a parent table changes, the database automatically updates the matching foreign key value in a child table to keep them synchronized. And then of course you got your delete, set null, and set default. And instead of deleting the child rows when the parent row is removed, the database sets the child foreign key. When you start deleting stuff and you try to delete something that might have a foreign key, you're going to get an error. And there's a way you have to truncate the whole data, not the whole database, but that particular table that you're dealing with, and that will help. So when you're deleting one that has the child that's pointed to that table, then you wouldn't have that error. So the database sets the child foreign key column to a null, and all predefined default value, severing the links, but keeping the child record. I guess that's what I was trying to do. So why use the cascading operation? Because you got like data integrity. That prevents orphan records. What is that? I forgot what it was. It's like the child roles pointing to a parent ID that no longer exists, which would otherwise corrupt the relational reports. Then you have the simplify application logic. That's when developers don't need to write sequential multi-table delete queries. A single command to the parent table cleans up the entire database, for you. And then you got your performance, right? Relationship engine that handles these operations internally at the database level, right? Which is why I wanted to do a whole thing about the SQL. That way, when you see the stuff that we'll do, that we have done, really, you'd be like, oh, I see where they put this information in. I see where they get, you know what I mean? I'm gonna do that. I'm gonna work on it so I get you. It'll probably be like, I don't know, maybe 5 videos. And then what else do we can deal with? Let's see. Let me take a sip of this right away, guys. And then you have your performance, right? That's the relational engine that handles these operations internally at the database level, which is faster and safer than executing multiple round trips query, which I kind of do sometimes, on an external application. The reason why I came here, because I'm going to be talking about this. See that the relational database execution, you got your traditional multi-ERP. That's like 33% efficiency. Then you got your standard web middleware. That's like 60%. Then of course you got our direct SQL relational engine. That's always about 95. But I think it would have been, somebody told me 95.95. But I don't know. I always found to be that it was maybe more, but okay. 95 is good enough. And by running the atomic calculation directly on an SQL relationship, we bypass the sluggish power of it. So what's multi? You say, well, what is that multi-herb? Is that the guy with the guns? No, that's wire. It's the multi-herb is like refers to an IT strategy where the organization uses multiple enterprise resource planning. That's what that is, enterprise resource planning system that across different subsidiary and region and business units, rather than, man, my tongue really hurts, rather than forcing the entire company to a single centralized platform, right? Because you got them on different places. And this approach is frequently used to balance like the corporate control with local operational flexibility. So key aspect of this multi-ERP strategy includes like 2 tiers ERP architecture. I mean, this the most common one, the form where a large robust system like tier 1 like SAP or Oracle handles the corporate level financials and operations, while smaller agile system like the tier 2, like, I don't know if you heard of it, it's called NetSuite or Microsoft Dynamics, run local manufacturing or regional office. Then you have this thing called a merger and acquisition. This allows newly acquired companies to keep their existing software, avoid the massive cost and disruption of immediate data migration. That's why it's important to, when you're creating these things, you got that in mind, that it could fall into any database. And then you got the integration needs that success heavily relies on the robust middleware or APIs to sync your data between the systems. And then, like for consolidated financial reporting. And then you say, well, what is the middleware? Well, the standard middleware is software that sits between a web server's incoming request and the final application logic, acting as a pipeline to inspect, modify, or reject requests and responses. And then you have your common types of middleware. You got your authentication, authorization. This verifies that the user identified, checks that the JWTs or session cookies, and the regular cookies I don't like, but session cookies I like. And it shows that they have permission to access the request route between letting the request proceed, logging and analytic the records, details about incoming requests like IP address, response time, HTTP methods for monitoring and debugging. And then you have like the body parsing, and that's intercepts a raw incoming request stream and parse them into accessible format like JSON, which reminds me that right now I can do what is that? That would have been a good thing. I think I'm going to add a way of putting a button that will use that instead of doing that. What is that thing that we use? And so in other words, to create JSON file. And a JSON file, once you send it to another company, then they can parse it and get that information. So it's much easier. Douglas Crawford, that's what came up with it. It's JavaScript. And a format like JSON and URL encoded data. Then you've got your security like the helmet, cords, add secure HTTP headers like to prevent vulnerabilities, like we talked about this, the XSS or click jacking. It manages cross-origin resource sharing rules. And then you got the clock rate limiting, so it prevents abuse. The DDoS attacks by limiting like how many requests an IP address can make within a specific time frame. And of course, we have the aggressive, no, not the aggressive, the compression. It compresses response bodies using the gzip Brody before they are sent to the client to reduce bandwidth and speed up load times. It's crazy, right? That is crazy. Let me see. Do we have another one? I think we might have done. Are we done? And of course, the warehouses time spent chasing errors, that's like 40%. Manual order copy, that's like 31%. And productive logistics, that's 30%. Look how low that is. It should be higher than the 40%. An average of 70% of administration costs are entirely preventable. Moving your logic to direct relationships lets you focus on more physical, stuff. Let me see, I wanted to go back to the direct. Let me see, did we talk about this part right here? Oh, I guess not. Like real quick, the pipeline works, right? So the middleware right here, that operates sequentially in an onion. It's like a first in, first out model. Remember that? And then you have your request phases. That request enters the pipeline, passes through each middleware layer sequentially, and logging, write, and authoring the rate limiting. And of course, you got your circuit. What is that? Your short circuitry. And that if a middleware layer catches an error or an unauthorized request, you can stop the chain entirely. And then return a response immediately by passing the final application logic. So when the response phases of the main application handles the request, of course, as the response travel back to the middleware layer in reversal order before being sent back to the user. So if I got, let me see, do I have anything else? Well, I guess I don't. I guess that was it. So I got, anyway, if you thought you find something of value, can give me a thumbs up and subscribe, and if you think I can improve on some things, or you want to know about some things, just add it in the comments below. Thank you very much. I got another one coming soon. We're going to be talking about it's part of the system, the purchasing order. I'll let you know when the time goes. It'll probably be the next video. Anyway, thank you, and until next time.